Hello everyone, and welcome to the last day of the unit of families of functions. We are on page 32 at the end. The idea that we finished in class on page 30 and 31, the idea that we looked at how knowing a y value and finding the x value is important in some situations. And so therefore we sometimes need to find the inverse function. That's what that's called. And if we look at the bottom of page 32, that's what it's saying right here. We often know functions and how to calculate values of one variable y. That's how we usually have it. Y equals 13x plus 2. We know how to find any values of y by plugging in x. But sometimes we'll want to do the opposite, discovering the values of x that will produce specific target values of y. If the function f shows how to use values of x to calculate values of y, then the inverse function shows the opposite. We talked about that. The inverse is the opposite. Shows how to use values of y to calculate for corresponding x values. Then the challenge is using the rule for f to find f inverse. And in class we looked at how to do that. We're going to finish that up here for 5 and 6. So for 5, I'll begin, and then you guys will finish this, and then we'll look at the correct answers afterwards. For each of the following linear relationships between y and x, describe the words describe in words the calculations required to find the value of x corresponding to any given value of y. So we have to solve for y. So what would we do here? Well, I'll do this first one. You guys are going to do B, C, D, and E. To solve for y, g of x, remember that's y, it says right there, you would get y divided by 3 equals x. Y is divided by 3, well, we got to solve for x. And so therefore you'd have to take y divided by 3, and that will give you any corresponding x value. So what you're going to do, B, C, D, and E, is solve for x, and then you can write in your own words, or at least think what you would do here. So I'll pause it. So you're going to do y divided by 3 equals x. So pause it. You guys are going to do B, C, D, and E. You're going to solve for x. And so here are the answers. I color-coded them, and D is over here. So pause it if you need to look at it. But all I did was solve for x, and then wrote down what I needed to do to find x to be by itself. So in D, in C, add 7, divide, I can spell that correctly, divide by 3. D is a tough one. If we got to remember to multiply by the reciprocal, so subtract 4, and then multiply by 5/3. Multiplying by 5/3 will, when multiplied by 3/5, will create that to be a 1, and the coefficient's a 1, so therefore you have x alone. And in E, subtract B, and then divide by m. So when we solve for the input, excuse me, the x variable, the input of a function, we call this the inverse. And so if we read here, when analysis of the relationship between two variables begins with the equation y equals f of x, it seems natural to express the inverse as x equals f inverse of y. And why do we say that? Well, this is in terms of y. All of these functions are in terms of y when solved for x. And it would make sense to write the rule using y as the independent variable. However, the convention in mathematical practice is to write the rule as a function of x as well, which doesn't necessarily make sense, but we always use x as the independent variable, so therefore we're going to keep it as that. So I understand that it makes sense to keep it as y, but we're not going to in this case. We're going to use notational convention to write these rules. And all we're going to do, and why I did this, is in 5, I already wrote the answers here. But see how they're in terms of y as the independent variable and x as the dependent variable? We just talked about right here how that's not how we write it in mathematics. And so If we look, we have y over 3 equals x. So if we write here y over 3 equals x, how should we write it in using in the correct mathematical way, even though it may not make sense, is we switch x and y, so it should be x over 3 equals g inverse of x. And by writing this g inverse of x, it makes it so that we don't have to, or so that we know, so that we know that it's the inverse function. Here, it makes sense it's the inverse function because x is solved for. Now we have to write it, if it's in terms of x, we have to write it as g inverse. And so I'm just going to go through here and rewrite all of these for you in terms of x being the independent variable. So here we go. I'll do this next one over to the side so I have some room. So h inverse of x equals x minus 5 over 3. J inverse of x equals x plus 7 divided by 3. I'll do the next one over here so we can see it. K inverse of x equals, now we did x minus 4. I'm going to put the 5/3 out in front, just so that we usually have the coefficient out in front. So 5/3 parentheses x minus 4. And the last one we'll do in black. S inverse of x equals x minus b over m. So the question is now, number 7 states that finding the inverses for nonlinear functions is generally a little more challenging. We're going to look at these two strategies. Strategy 1 is exactly what we did. We had the original function, we multiplied by x minus 2 to the other side. We then divided by y, or we would have, and then add 2. You solved for x first. That's exactly what we did in 5. And then what we did in 6 was we said conventional mathematics says you don't have y as the independent variable, and therefore we switched x and y at the end. Notice that we switched these and wrote y as f inverse of x to show that we've solved for the inverse function. Strategy 2 says you swap the roles of x and y first. So we switched x and y first. Then solved for y, and then replaced y with f inverse of x. Strategy 1 should make more sense because that's how we did numbers 5 and 6. We solved for x, we solved for the opposite variable, and then replaced it with f inverse of x. Strategy 2 is maybe a little easier because we switch x and y immediately and then don't have to switch at the end. So most students like strategy 2 because we switched x and y in the very beginning and then you don't have to remember to switch at the end. And so if you would like to go with strategy 2, I completely understand. So let's look and recap here on how to find some nonlinear function inverses. So in A, we have g of x equals 7 over x plus 4. If we use strategy 1 to solve for the inverse of g of x, we'll do that right now. We get y equals 7 over x plus 4. We will subtract the 4 first. So y minus 4 equals 7 divided by x. If you have a fraction, we can multiply by x to get x to the other side. So now we have x parentheses y minus 4 equals 7. Notice that when we multiply by x, those x's become a 1, so you're just left with 7 times 1. We're solving for x because we want to get the opposite variable alone. It's not already solved for. We already know y solved for. we divide by y minus 4. And we are left with x equals 7 over y minus 4. And then we switch x and y, this is exactly what we did here, to get, and it's g of x, so we're going to get g inverse of x equals 7 over x minus 4. I double stepped there, did a double step in the sense I switched x and y to make this y, and then I wrote it as g inverse of x. To do the strategy 2 way, you're going to switch x and y to begin with. So we're going to have x equals 7 over y plus 4. And now the goal in strategy 2 is to solve for y. So you're going to do the same thing. Subtract 4. Multiply the y over to the other side. Y parentheses x minus 4 equals 7. Divide by x minus 4 to get y alone. To get y equals 7 over x minus 4. And because we solve for the inverse, you need to replace it with g inverse of x equals 7 over x minus 4. Either strategy is correct. Please understand that. Either strategy is correct. So to finish off the notes, I would like you to try B and C. So pause the video, try B and C, and then we'll finish up the rest of the notes in class. So try B and C. And here are the answers to B and C. Please check them, look it over. I use strategy 1. If you use strategy 2, that is perfectly fine. Please do not think that's wrong. It's perfectly fine. So check that over, highlight or star any questions you have, and I will see you in class.